Okay, welcome to the problem solving video for the differential equations unit. So we have three differential equations, three initial conditions. We need to try to solve the differential equation if it's separable. If it is, solve it. If it's not, that's it. I'll also go for A. We have dy dx is equal to the natural log of x to the y, and our initial condition. So when you see y prime, just note that means dy dx. It's just in that alternate notation to confuse you. And then you should know the logarithm property for exponents. If you have something like this, you can just bring this down and you get y ln x. So this is equal to y ln x. Let's trace this. And then now you can see this is a clearly separable equation. I can bring the y down and I get 1 over y dy is natural log of x dx. And then I can integrate this now. The integral of 1 over y is pretty straightforward. It's the natural log of the absolute value of y. But this natural log of x, this is a bit trickier. You have to use integration by parts, which is why I gave it to the students in AB. But if you're in BC, you should have done this out. I'll do it real quick just for you to check. So we have u is ln x, du is 1 over x dx, dv is dx, v is x. So we have x ln x minus the integral of x over x dx, which is x ln x minus x plus c, and plus c goes there as well. So this is x times the natural log of x minus 1 plus c. Okay, and plugging that back in, we have x times the natural log of x minus 1 plus c. And then solving for y, we're going to raise everything here to the e power. Is that to the e power? Is that to the e power? And this cancels, so we get y is equal to e to the x, that stuff. And then when we have e to the two exponents being added together, it's basically the same as the two things being multiplied. So what that means is you can take this and then multiply it by e to the c, and then e to the c is just another constant, right? It's just another, e is a constant, c is a constant, so e to the c is a constant. I can just replace this with one big C, so we get c e to the x ln x minus 1. So this is my equation, my final equation, and I need to figure out the value of c now by plugging in my initial condition, which is 1 comma 1 over e. Let's write that down. 1 comma 1 over e. So plug in 1 over e for y, and I get 1 over e is equal to c, e to the, and then plug in 1 for x, which will be 1 times the natural log of 1 minus 1. The natural log of 1 is 0. 0 minus 1 is negative 1. So 1 over e is equal to c times e to the negative 1. And e to the negative 1 and 1 over e are the same thing, so they cancel. We're just left with c equals 1. That means in this original equation, c is 1. So I'll just write my final answer as y is equal to this. And that's our answer for part A. Let me just erase and we'll do part B now. Okay, part B, we have dy dx is equal to this gigantic trig mess. So let's see how we can work on solving that. And of course we have this initial condition. Let's see. So dy dx, and then, so what we can do here is we'll take this, we'll separate the y's and the x's. So we'll say dy dx is, and there's just one y, it's the 1 over sine y. And then we have 4 sine x over cosine x times 1 minus tangent squared x. And then, so sine over cosine gives tangent. So I can say this is 1 over sine y. And so I can write this as 4 tangent x over, there's no cosine anymore, yeah? Over 1 minus tangent squared x. And this should look really similar to the form of the double angle formula for tangent, which is tangent of 2x is 2 tangent x over 1 minus tangent squared x. And the only thing is, instead of a 2, we have a 4 here. What that means is this is going to be equal to 2 tangent of 2x. And then this is still equal to dy dx. And now it's a lot easier to separate. So bring this sign over here. I'll get sine y dy is 2 tangent of 2x dx, and then I'll integrate both sides. The integral of sine is negative cosine, and then the integral of 2 tangent 2x, that's going to take a few steps, so let's do that down here. First, we'll start with u substitution to get rid of the 2's. We'll say u is equal to 2x, du is equal to 2, so this is the integral of tangent of u, du, and then we can say, alright, tangent is sine over cosine, so this is just sine u over cosine u, and then when you're choosing what to do for your substitution, always choose the one on the bottom, or at least usually, so we'll choose we're going to choose to substitute a variable for cosine u, but since we're already using u right now, we'll use v. We'll say v is cosine u, dv is equal to negative sine u du, and then it's going to cause this to be the integral of 1 over v dv, negative the integral 1 over v dv, which is negative natural log of absolute value of v. And then remember, v is just cosine of u, so this is the negative natural log of the cosine of u plus c. And then u, what is u? Well, u is, look up here, u is 2x. So this whole thing is the negative natural log of the cosine of 2x plus c. And then I can take this and I can say, alright, this is equal to the integral of 2 tangent of 2x. So I'm going to copy paste this into up there. I love copy paste. Okay, now let's see what we can do. The negatives are going to cancel. We'll take the inverse cosine of both sides to solve for y. So y is the inverse cosine of the natural log of the cosine of 2x plus, hang on. The plus c is going to be inside of the inverse cosine, since we're taking the inverse cosine of the entire side. So it'll be there. It'll be there. And then let's look at our initial condition now. Initial condition is pi over 2 and 2 pi over 3, right? So I'm gonna move this to somewhere where it's easier to just work with a bit. Okay, copy paste is finished. And the point was, what was the point? It was pi over 2, 2 pi over 3. Pi over 2, 2 pi over 3. Now we just plug that in. We'll plug in 2 pi over 3 for y, being equal to the inverse cosine of the natural log of cosine of 2 times pi over 2 plus c. Okay, so let's see. What is 2 times pi over 2? Well, it's just going to be pi. What's cosine of pi? Negative 1. What's the absolute value of negative 1? 1. So I think that's enough steps. We'll say 2 pi over 3 equals the inverse cosine of the natural log of 1. Right? So this whole thing is equal to 1 plus c. And then what's the natural log of 1? Well, it's 0. So 2 pi over 3 is the inverse cosine. It's going to go to 0, so we just have the inverse cosine of c. So what this is asking is, the inverse cosine of what is 2 pi over 3? So to figure that out, let's think about the domain for the inverse cosine function. So the inverse cosine function, its domain is in the first and second quadrants. And since this is in the second quadrant, our c is going to be a negative number. So the cosine of what? The cosine of 2 pi over 3 is going to be c. And that is negative 1/2. So that's our c value. And then plugging that back into our original equation, we'll get y equals the inverse cosine of the natural log of cosine of 2x minus 1/2. And with that, we are done with that. Now let's move on to part C real quick. Okay, finally, we have dy dx. Let's write it. I'm still in that color. dy dx is 2, I'll just factor out the 2 right now. Sine x cosine y plus sine y cosine x. And again, from your knowledge of trig, this is the formula for sine of x plus y. And then we can plug that in and we'll get dy dx is 2 times the sine of x plus y. And how do we split this up? Well, you can try to find a way, but I don't think it's going to be possible. This is not a separable differential equation. Okay, so yeah, we're just going to stop there because there's nothing we can do. And then let me just write the words not separable. We're done with that, and now let's move on to question 2. Okay, now to question 2. So we have the population y is growing according to this differential equation, where k is a constant, t is measured in years. If the population doubles every 10 years, what is the value of k? Okay, so what we need to do is we need to first write this in the equation that doesn't have a dy, just has the y. And that equation is y equals y initial times e to the kt. And then we'll see what we're given. So we're given that the population doubles every 10 years, right? So if we have the initial population y0, then if you go 10 years, you'll get 2y0, right? So we have our initial population, we have our time, and then we have our final population. This is going to be equal to y, right, the final population. So now I can just plug all that into our equation, and instead of y, I'll put 2y initial equals y initial times e, and then our t is 10, so we'll put 10k, and then the y's initials cancel, and I have 2 is equal to e to the 10k, and this is just a matter of solving for k, so I'll take the natural log of both sides, and get the natural log of 2 is equal to 10k, and then just dividing both sides by 10 gives that k is the natural log of 2 over 10. I'm not going to simplify it, I'm just going to leave it as is. So that's the answer for question 2. Next question. Okay, so question 3. This is a perfect example of all the bad things that can happen when you let a 16-year-old write a math problem. Not good. So anyways, let's look at part A. So this is town populated by proboscis monkeys, which are amazing animals. And we know that in the year 2017, the population is 13,000. So it looks like we're starting in the year 2017. So I'm going to call that this t equals 0. That's our starting time. And then in 2020, the population grew to 16,000. So when they give us this extra tidbit of information, the point of that is to help us find the k value. So remember the equation y equals y naught e to the kt. We know the initial population is 13,000. We know that the final population is 16,000. And what is t? Well, in 2020, that's 3 years from 2017, so t is 3. So that gives us 16,000 equals 13,000 e to the 3k. And then once we solve this equation for k, let me pull out the calculator. And then this is our k value. And remember, I said never round your k value when you're using it in problems. So I'm going to store this in the variable a. Store. Okay, so it's a different notation. The variable a. So now whenever I type a, this is what's going to come up. And just from somewhere I did here, I divided both sides by 13,000. So 16 over 13 equals e to the 3k. Took the natural log of both sides to get rid of the e. So the natural log of 16 over 13 equals 3k. And then I just divided by 3. It's all for k. And we got this number here. And then now what we can do is we can use that. And let's look at part A now, like see what's asking us. In what year will the population reach 42,069? So we know that the initial population is 13,000. The final population is going to be 42,069. And then the k value is whatever I have stored in the variable a. Okay, and then I can use the same equation again. That's not supposed to be a y0, is it now? So I can use my equation y equals y0 e to the kt. Now remember, I want to solve for t now, so I'll do the same thing, and I'll get t is equal to the natural log of y over y initial over k, which will be the natural log of 42,069. I'm just pulling the information from over here, over 13,000, and all that divided by a. So that's going to be, and that gets us 16.96. Yeah, so 16.96. And remember that we're starting in the year 2017, right? That was where we had the population of 13,000. So 16.96 years from 2017 is going to be 2017 plus 16 is 2033. I'm not going to round this because we want the year that it actually happened, not the next whole year. So 2033 is the answer for part A. Now let me erase and work on part B real quick. Okay, now let's look at part B. The town is invaded by a group of blobfish, which are my other favorite animals. 3 blobfish entered the town in 2021. So now t equals 0 is going to be the year 2021. And so the initial population is 3, and by 2024 there are 10,000 blobfish. Assuming this is all possible and ignoring the vast genetic problems that this might cause, yeah. In what year will the population of blobfish equal the population of proboscis monkeys? So the first step here is going to be, again, finding the k value for the blobfish. So again, I've done this a bunch of times, k is going to be the natural log of this, right? So this is from like the stuff we did in part A. So this is going to be, and what are these variables? Well, y is our final population, which is 10,000. Y naught is our initial population, or 3. And then t is, so how many years passed between 2021 and 2024? That's 3 years. So this is our 300, and this is going to be the natural log of 10,000 over 3, and that over 3. And that's going to be, and I'm going to store this in the variable b. We still might need a again. So that's approximately equal to 2.704. Okay, and now, so I know that, I'm going to write 2 different equations here. One for the blobfish and the other for the proboscis monkeys. So the population of the blowfish is the initial population of the blowfish times e times the k value of the blobfish times t, and the exact same thing for the monkeys. And then we want to find the time when the populations are equal. So these 2 things are going to be equal. So I can set these 2 equations equal to each other. And now, if you didn't have a calculator, you'd have to solve this equation for t. But since we do have a calculator, I'll say, okay, what are each of these values? So let's make it like a little table here. Not really a table, but it's like a list of values that we know. We need KB, and then we need Y initial population of the monkeys, and then the K value of the monkeys. Okay, so let's see what we know here. We know the initial population of the blobfish is 3 in the year 2021. Oh, but all of this is going to be for 2021, right? And the K value is going to be the same for, that's going to be our variable B. And then the initial population of the monkeys, well, we can't use 16,000 because that's the initial population in we can't use 13,000 because that's in 2017. We want the population in 2021. So we're going to have to figure out what this is by finding out the population of the monkeys in 2021. Okay, so let's figure that out first. So let me scroll down a bit more. So to figure this out, I know that the initial population for the monkeys in 2017 is 13,000. I know that the K value is whatever I said it was in A. And then the time is, the whole point of this is to figure out the population in 2021. So the time is going to be 4 years, because 2017 to 2021. And then this means I want to figure out what is the initial population of the monkeys at 2021. Yeah? So then I'm just going to call this Y. And I'm going to say this, and then solve this equation. It's going to give me, it's going to give me 17,147. So this is the population of the monkeys in 2021. Okay? So we'll put that in, 17,147, into here. And then the K value for the monkeys is going to be A. So now we have all the values that we need. So I'm going to take this here, and I'm going to plug in my value. So I know this is 3. And I know KB is B. T equals, I know this is 17,147. I know this is A. T. And then now we're just going to use our calculator. So this is going to be in Y1. This is going to be in Y2. We're just going to graph these two and we're going to see what happens. I'm just going to graph this and then find out where they intersect. So let's just wait for this to load real quick. Okay, it loaded. So we're going to find the intersection point of the two curves. So second trace 5. Spam the enter button. And we're going to get Y is equal to 3.28. Yeah, 3.28. So T is equal to 3.28. And remember, this is starting in the year 2021, right? So 3 years from then is where the population is going to be the same. So 3 years from then is going to give me my final answer of 2024. That was part B. Now let's erase all the stuff and look at part C. Okay. Nothing happened. I totally didn't just crash right there. Anyways, so looking at part C of the problem, in an alternate universe, a pandemic that turned all the monkeys pink struck the town, forcing all the monkeys to practice social distancing and stay inside their homes. Because of all the free time that people have, the population in 2020 increased to 20,000. I'm not going to go into the details of that. How many years quicker will this population reach 42,069 compared to the original population, the original universe? Yeah. So now we'll set up another equation. So again, we know that the initial population is the same as 13. There's still 13,000. We know that now the final population is 20,000 in the same time of 3 years. So let's find out the new K value. So K is the natural log of Y over T. Pulling up our calculator. Okay, that is the natural log of 20,000 over 13,000 divided by 3. Alright, I'll store this value in another variable. I don't know. I'll call it, well, why not just call it K? That makes sense. Store that to K. Alright, so now let's see what we can do. So we know we want to find out when this population reaches 42,069. So we'll say, alright, the initial population is 13,000. The final population is 42,069. The K is, well, the K value that I gave. This is our equation. And we're solving for T. right? So we know our y value, we know our y initial value, and we know our k value. So that's going to go straight in the calculator. We're going to get the natural log of 42,069 divided by, what's our initial value? 13,000? Yeah, 13,000. That divided by k will give us 8.178, yeah? So this is years since 2017, because 2017 is our initial population. So since we started in 2017, this occurs in 2017 plus 8, or 2020, or equals in 2025, right? And if you remember from part A, we had 2033. So the difference between these two parts is 2033 minus 2025, which is 8 years earlier. So this new population, because of the social distancing stuff, again, I'm not going to get into the details, but they reached this population of 42,069 8 years earlier than the original population would. Okay, that was problem 3. Now let's move on to the next one. Okay, if you're in AB, we've finished. But if you're in BC, we're going to have to deal with this logarithmic problem now. So we have this guy Fred. Fred cheated on his calculus test, and the news is ripping through the school. On day 0, only he, his teacher Romeo, and his friends Jesse and Olivia know about it. Jesse was not a faithful friend of Fred, however, and began to tell the school at a rate modeled by the differential equation. There it is. One day later, there are now a total of 50 people who know, including the original 4. Again, remember, this is when they give you that extra tidbit of information, that's to help you find the k value, which fits with part A, which asks us to find the k value. So let's do that, shall we? So remember, since this is a logarithmic, we're not going to use the same equation as we did in the first questions. We're going to use this equation. P is the population, is equal to m, which is the carrying capacity, over 1 plus a e to the negative kt, where we already know k, we already know t is time, and then a is this other variable, defined as a is m, which is again the carrying capacity, minus the initial population, divided by the initial population. Okay, so we need to figure out all these values. Let's see what we can figure out so far. So in this equation, dp dt is equal to kp 1 minus p over 2500. You should know that the original form of this equation looks like this. So the original form is dp dt is kp times 1 minus p over m. So in this case, since there's a 2500 here, that means this m is 2500, right? So now we know m is 2500. That's the first piece of information. Second, we know that the initial population, which is the population on day 0, and by population, by the way, I mean the number of people who know that Fred cheated, because cheating is bad. So the initial population is on day 0, he, Mr. Romeo, Jesse, and Olivia, so 4 people total, know that he cheated. And then after 1 day, so when t equals 1, the population is 50, including the original 4, so a total of 50 people. And then we can use this, so we know m, we know p, and we need to find a, yeah? So let's use this equation to find a, because we know the initial population, and we know the carrying capacity, so we can use those two variables together to find find a. A is 2500 minus 4 divided by 4, which is 624. So now we know a is 624. So let's see if we can figure out this stuff. We know p, we know m, we know a, we know t. So now we can put this all together and figure out k. So let's write it over here. I'll write that 50 is 2500 over 1 plus 624 e to the, so since t is 1, I'll just say negative k. And this is just a big game of solving for k. Let's bring this entire bottom over to the other side. 1 plus 624 e to the negative k equals 2500 over 50 is 50. And then I'll subtract 1 and then divide by 624. So then e to the negative k is 49 over 624. A bit. And then taking the natural log of both sides, I'll get that negative k is the natural log of 49 over 624. And then just bring the negative over there. K is the negative natural log of 49 over 624. And that's my k. Again, I'm going to leave it as the exact form. I'll only do anything else if I need to use it in another problem. So let me just erase and we'll look at the next part. Alright, now let's look at part B. By the way, I've written here that k is this, which we found in part A, and it's approximately 2.544, and this means I've gone ahead and stored it in my calculator as the variable a, so I can use it if we need to later on. Okay, so part B, we're asked to write the logarithm equation p equals whatever. So that's just, remember how we had the equation p is equal to m over 1 plus a e negative kt. This is just plugging in all the numbers that we got from the other part. So m is 2500. A is 624. K is 2.544. Or you know, I'm gonna use this form. So if I multiply the negative times the k, the two negatives are gonna cancel and make a positive. So we'll get a positive ln 49 over 624, and then multiply that by t. So that's my specific logistic equation for this problem. And then that was part B. I don't even need to erase, that's so small. Part C. Using your calculator, determine how many students know he cheated after 2 days. So we want to find out how many people cheated after 2 days. So I'm going to take this equation, right? Let me take this equation here. Take that equation here. And then for t, plug in 2, because the time is 2. And this is going to go straight in the calculator. And we're going to get... that's definitely not right. What is it? Oh, yeah, okay, so this is supposed to be negative there, since this is negative of our a value. So then we get, okay, that's a lot better. We get 515. So 515.7. I'll round it up to 516 people. That's how many people know the rumor after 2 days. That was really, really quick. Okay, so let's pause. Okay, final part. When is the rumor spreading the fastest? Okay, so remember that the rumor spreads the fastest when the population is half of the carrying capacity. So when p is equal to m over 2. Since m is 2500, this is 2500 over 2, or 1250. So let's plug that into our equation, and we get 1250 equals 2500 over 1 plus 624 e to the ln over 624t. And then we want to figure out what's the time that makes this true. So let's solve this equation for t, bring everything over to the other side, bring the 1250 down here, and we get 1 plus 624 e to the ln 49 over 624 t. This is equal to, well, 2400 over 1250, we just set up here is 2. So then subtract 1, makes a 1. Divide by 624. is 1 over 624. And then now I'm going to graph this. I'm going to graph this on y1 and y2. Let's pull up the calculator. Go to y. Okay, so I have, on one side I have e to the natural log of, well, I can just do my variable, right? I can just use, since k is the negative natural log, I want that just the plain natural log, so it's going to be negative of k value times x, and then I'm going to have 1 over 624. I'm using x because that's the variable I'm solving for in the calculator. So graph, let's wait for this stuff to load. Okay, it loaded. So second trace 5, so we find the intersection point, spam the enter button, and we get x is equal to 2.5296. So t is 2.5296 days. So this is the time when the rumor is spreading the fastest, because this is when the population is half of the carrying capacity. Okay, so that was this problem, and now we just have one quick problem on Euler's method next. Okay, so we're given an Euler's method question. We have 3 equal steps to approximate f of 1, given f of 1.3 is 0.7. I'm sorry, I couldn't come up with a fun way to word this one. So our delta x is going to be 1 minus 1.3 over 3. Just negative 0.3 over 3 is negative 0.1, right? Let's just get that out of the way real quick. Then we can set up our table. So we have start, dy dx, m delta x, and nu y. I can spell, I promise. Nu y. So we're going to start with the point 1.3 comma 7. And then for an x value of 1.3, dy dx, or f prime of x, is 3. So we're given that. We don't have to calculate it with a differential equation or anything. So m delta x. This is our m, right? This is our slope. Our delta x is always going to be negative 0.1. So our m delta x is 3 times negative 0.1, or negative 0.3. And then our new y is going to be this y, 7 minus the, or plus this, so minus 0.3. 7 minus 0.3 is 6.7. We're going to put that in. So 1.2 comma 6.7. So for 1.2, f prime of x is negative 1. Negative 1 times negative 0.1 is positive 0.1. And 6.7 plus 0.1 is 6.8. And then 1.1 comma 6.8. So 1.1, our dy dx is 2. M delta x is going to be negative 0.2. Again, 2 times negative 0.1. And then 6.8 minus 0.2 is 6.6. So what we have is 1.0 comma 6.6. Remember what the question asked us to do? You said to use Euler's method to approximate f of 1. Well, I think we just did that. We said y value is going to be approximately 6.6. So that's our final answer. F of 1 is approximately 6.6 using Euler's method with 3 equal steps. If you found this problem solving video helpful, and I will see you in the next one. Goodbye.